Hi, my name is Sandeep and today I'm going to talk about cloud computing. My talk will cover what is cloud computing, where it came from, and why it matters to you. Let's start with what is cloud computing. Basically, it is the realization of a very long held dream of utility computing. Let's understand what is utility computing. So, let's assume the tap water didn't exist. In that case, everybody needs to dig a well, which is very expensive to build and very expensive to maintain. There are certain challenges in that. Let's assume that you don't need the well anymore. Then, in that case, basically, you have invested in something which is of no use after a given period of time. What do you do with that well? Let's assume you are changing your house. You cannot take the well with you. That also is kind of loss of investment for you. A third scenario, let's say you need more water on a given day. You cannot get that immediately unless you upgrade your pump or either dig the well more. So tap water basically solves all of these problems. Someone else spends the money and builds the right plumbing infrastructure for you. They manage it and ensure that the water is clean and always available. You pay only for what you use. You can always get more if you want it. That is all what we call as utility computing, or that is all what we call as cloud computing. It is basically data center resources which are delivered to you like tap water. It is always on and you just pay for what you use. And that is what cloud computing is all about. Now let's understand from where this term cloud came from. So it is nothing but a metaphor of the internet. So if you look at various network diagrams, internet is always shown as a cloud which connects or which is a medium between two or more entities. And as we discussed, utility computing is paying for the use of resources on a metered basis. So the moment you start using a particular resource, the meter is on. It captures the reading of the usage and then you are charged on basis of the usage. Now let's understand the history of cloud computing, basically from where it came from. So as I was telling you, it is a long held dream. So it started with the time sharing systems concept when we used to utilize the time between multiple IO cycles to process multiple instructions. IBM was one of the major players who used to provide pay per use model or pay for play model for time sharing systems. Those systems went out of fashion with the rise of personal computers. The second one is mainframe computing systems. So, although mostly outdated today, mainframe computing innovated several of the ideas that cloud computing offers in today's world. Few of them are computational speed, then reliability, the redundancy built into the internal system, and then high availability of the systems. These were some of the key characteristics of mainframe computing systems that in today's world cloud computing offers. In today's world, nearly 75% of the systems are transactional systems. They are the building blocks for the modern services. The technology behind transactional systems is instrumental in modern cloud services. Transaction systems allow processing to be split into individual operations, which we call as transactions. And each transaction follows the ACID properties, which is it is atomic, and transactions are basically fundamental part of every modern database system. The next one is grid computing systems. The term grid computing basically started or originated in somewhere in 1990s and referred to making computers accessible in a manner similar to the power grid. This sounds a lot like cloud computing, but there is a little difference. Basically, grid computing is about using few but very large requests for data access or data storage. Only a few of these allocations can be serviced at any given time, and others must be queued. Cloud computing, on the other hand, is about lots of small allocation requests and the allocations happening in real time. So that is the basic difference if you look at between cloud computing and grid computing. The most famous grid computing project is ACTI@home. You can search about it and find out more about if you are interested in learning more about grid computing. But from a history perspective, grid computing was the last one in the series of what cloud computing offers today. So let's look at various characteristics of cloud computing. And the first one being the illusion of infinite resources. Why we included illusion here is because there will always be a limit that you must keep in mind. Nothing is infinite when it comes to resources. So everything has a limit, and that's why it creates an illusion. As a user, you are not required to do the kind of capacity planning that may be necessary to deploy your own individual storage and computing infrastructure. You can depend on the companies you are dealing with to own several large data centers spread around the world. And that's where you assume that you have infinite resources. The second characteristic is about scale on demand. All the cloud platforms allow you to add resources on demand, or I would also say they allow you to decrease the resources on demand. So you can increase and decrease resources as the demand grows up and down based on your needs. And this basically a very good thing in terms of time and cost, because the kind of provisioning the cloud computing services provides you does not require a lot of time to add resources or remove resources. So is the cost, because you are going to pay always for what you are going to use. You don't have to worry about what happens if you don't need the resource anymore. That means you are not charged for that. Then pay for use or pay for play, as we discussed, you pay only for the software and hardware you use, nothing else. The next one is high availability with SLAs, service level agreement. So if you choose to depend on someone else to run your business, you must be assured that you won't be subjected to frequent outages. Most cloud providers have a service level agreement that guarantees a level of uptime and includes a refund mechanism if the SLA isn't met. Windows Azure provides an SLA for both its storage and its hosting pieces. So from that point, both of hosting as well as storage are covered under SLA in case of Windows Azure. The next property or characteristic is geographically distributed data centers. When serving customers around the globe, it is critical to have data centers in multiple geographic locations. Reason for this requirement include legal or regulatory concerns, geopolitical considerations, load balancing, network latency, and so and so forth. In short, cloud computing is more like your water or electricity provided. It is always on when you need it, and you pay only for what you use. Now let's focus on the current state of cloud computing. So there are certain perceptions uh, about cloud computing, like somebody tells it is the end of software and everything will be a service. Someone tells on demand infrastructure, everything will be on demand. You don't have to create your own infrastructure. It's cheaper and better. Well, let's see the reality. It's a hybrid world. You have to mix and match. It is not about all or nothing. Secondly, it is not the end of the software. You can still leverage your existing IT skills and your investments. It provides you seamless user experiences, and it is evolutionary, not revolutionary. It is evolving as the processes, the services, the tools are getting better and better day by day. And the drivers behind cloud computing is ease of use, convenience. You don't have to manage resources, somebody else is doing it for you. Then product effectiveness and simplifying IT to reduce cost. There are a couple of types of cloud computing. There are public clouds, private clouds, internal clouds, external clouds, and hybrid clouds. I'll explain these types in details in upcoming webcasts. There are multiple categories of cloud computing: software as a service, platform as a service, and infrastructure as a service. Let's understand what is infrastructure as a service. So it basically refers to the services that provides lower levels of the stack. They typically provide basic hardware as a service, things such as virtual machines, load balancer settings, and network attached storage. Amazon Web Services and GoGrid fall into this category. The second one is platform as a service. So if you look at providers such as Windows Azure and Google App Engine, they provide a platform where users can write their code. And here platform refers to an abstraction between the lower level details of hardware and to the program. So it is basically a service. It is sometimes restricted environment where you are running as a low privilege process, so and so forth. But you typically write your application in a controlled fashion where the hardware is managed by the provider or the platform, and you just manage your application on top of it. And Windows Azure falls into this category. The next category is software as a service. The canonical example of this model is Salesforce.com. Here, the provided applications can be accessed from anywhere in the world. For example, the Microsoft Exchange Online or Microsoft Office Online. Those are the services which are available throughout the world. From anywhere you can access it, and then you pay for use. With this, I will end my talk here. In the next talk, I'll be talking mostly on Windows Azure, which will be an introductory session on what Microsoft Windows Azure Estate offers in terms of tools, in terms of technologies, and how we can leverage it to build applications. Thank you very much. Talk to you soon.